Hi students, in this video we will discuss techniques of Turing machine construction. Techniques of Turing machine construction. You know what is Turing machine? Turing machine is a powerful abstract machine that could simulate modern day computer, but very slowly. You know this is the base of our general purpose computer. And why to design such a machine? Why I need a machine? Right. So there are two types of questions or two types of problems, that is decidable problems and undecidable problems. Assume I have a problem statement and if I could write an algorithm for that problem. You know what is algorithm? Algorithm is nothing but step-by-step procedure to solve that problem. If I could write an algorithm for that problem and if I could solve it, right, then solution may be either yes or no, but if I could solve it, I can say it is decidable problems. I can decide the solution for that problem. Right? Suppose there are some problems, right? I cannot solve it. There are some problems that I cannot solve it. Such type of problems are known as undecidable problems. Right? I cannot write the step-by-step procedure, or even with my Turing machine also, I cannot get a solution for such type of problems that are known as undecidable problems, right? So why I say this Turing machine can simulate modern day computer means, right? If a problem can be solved using a Turing machine, then only it can be solved using the computer also, right? Such type of problems are computable, right? If I could solve using Turing machine, then only I can solve using my general purpose computer also. Right. Next is techniques of Turing machine construction. First is Turing machine with storage. I can construct a Turing machine with storage. Right. So why I need this storage? Assume I want to design a Turing machine that remembers its first uh, symbol in its input string. It should remember the first character of its input string, and it has to check that this first character should not be present in the remaining input string. That is, if my first symbol is 0, this 0 should not appear in the rest of the input string. Or if my first symbol is 1, this 1 it should not be present in the rest of it input string. That's what I have written here. First symbol 0 means, right, next I should have any number of ones. I cannot have a 0. If my first symbol is 1, I cannot have 1 in the rest of the input string. I cannot have 1 in the rest of the input string. I should have only any number of zeros. Right. So if I want to design here, you can check it has to remember the first symbol. It has to remember the first symbol. Then only it can check whether this first symbol is appearing again in the rest of the input string. So what I can do is like, this is my Turing machine. I can design a Turing machine with a storage. In this storage, I can put my first symbol so that my Turing machine can remember the first symbol. Right, this is my Turing machine. Tape of your Turing machine, read write head, and I have a storage. What is the role of this storage? This storage will remember your first input string. First input string. Right. Then how to write the transition for Turing machine with storage? Right. In writing the transition for Turing machine with storage, I have to write the state and the symbol to remember together. Right, I have to write the state and the storage symbol together. That's what I have written here. See, initial state is Q0, initially it will be blank. It is reading the first input symbol. Turing machine is reading the first input symbol. Assume if your first input symbol is A. Right, this A I have to remember it. So what am I doing here? I am making a state change. Initially it was Q0. I am making a state change and I have to remember my first input string, right? So I'll write q1 comma a together. State and my storage symbol together I have to write that. Then like the ordinary Turing machines, your input string A and I am traveling in right direction, right? So when it reads the next input string, how I am designing this Turing machine, it should read its first input string, it should remember it, and it should check whether this first input string is not repeated in the rest of the input symbols, right? So Q1, this Q1 current state and my storage symbol. In the next transition, you specify Q1 comma A, and definitely my input symbol, it should be A complement, right? You can check 0 first symbol, remaining symbols it should be 1 star. So if it is A, remaining symbols it should be A complement. That's what I have written here. So it will be Q1 comma A complement. Again it is traveling in right direction. Right. So for this purpose, if I want to remember any input symbols, I can design my Turing machine with storage property. Right. Next is multi-track Turing machine. What is this multi-track Turing machine? It has a single tape but multiple tracks. Single tape is divided into n number of tracks. Since I have only one tape, there will be only one read-write head only. Right, only one read-write head. But this single read-write head will read all the tracks, symbols from all the tracks at a time. At a time, it can read the symbols from all the tracks. It will read the symbols from all the tracks. That is my multi-track Turing machine. Single tape is divided into n number of tracks. Since I have only one tape, there will be only one read-write head, but this read-write head can read from all the tracks at a time. It can read from all the tracks at a time. Same thing, multi-track Turing machines. Right, so what we have learned in this video, we have learned TM constructions, right? A TM construction. So here we can construct a Turing machine with storage, or we can construct a Turing machine with n number of tracks. That is multi-track Turing machine. And in the next video, we can discuss about variants of Turing machine. Thank you.